Welcome to section 11.2, Rational Exponents. The use of rational exponents follows from our properties of exponential notation and what we really mean by the term radical. Recall that what we mean by the nth root of a number is the nth root of the number x raised to the n power gives us x. If we imagine that the nth root of x was x raised to some unknown power p, then using this property we actually have x to the p raised to the n power, which is x to the pn. By the property of the power raised to a power, we multiply the exponents. This actually gives us x to the first power. So this means that p times n has to be 1. We simply say that the exponent on the left is equal to the exponent on the right. Solving for p, this gives us p is equal to 1 over n. This is where we obtain the property that the nth root of x is really x to the 1 over n power. At this point, it's probably a good idea to review all of our properties of exponents. We have the multiplying like basis formula. We add the exponents. Dividing like bases, we subtract the exponents. Having a power to a power, we multiply the exponents. A product to a power, the power distributes to each base. The quotient to a power, again the power distributes to each base. Anything non-zero to the 0 power gives us 1. X to the negative n is equal to 1 over x to the n power, again x not equal to 0. And the nth root of x is equal to x to the 1 over n power. More generally, we have the nth root of x to the m power is equal to x to the m over n power. For example 1, let's suppose that we are asked to rewrite with rational expression, with rational exponents, the expression the 6th root of x to the 7th power. Simply using our properties of exponents, this gives us the 6th root of x to the 7th is x to the 7 over 6 power. If we are asked to write the expression in radical form, c to the 3/8 power, once again using the same property, we have c to the 3/8 is the 8th root of c cubed, or we can write this as the 8th root of c raised to the 3rd power. Suppose we are asked to simplify the radical, the cube root of x to the 12th power. Rewriting this in with rational exponents, we have the cube root of x to the 12th is x to the 12/3 power. 12 divided by 3 gives us x to the 4th power. Using rational exponents, we wish to simplify the expression the cube root of the cube root of x. Once again, writing this with rational exponents, the cube root of the cube root of x becomes x to the 1/3 power raised to the 1/3 power. Using our power to a power property, we multiply exponents to give us x to the 1/9 power. The 1/9 power then becomes the 9th root of x as our final answer. Now let's use radical notation to rewrite the expression and to simplify 27 to the 2/3 power. Rewriting this in radical form, 27 to the 2/3 power becomes the cube root of 27 squared. The cube root of 27 is simply 3 because 3 times 3 times 3 gives us 27. 3 squared, then simplifies to give us a final answer of 9. In this case, let's suppose that we are asked to use radical notation to simplify the expression -9 to the -1/2 power. Using our properties of exponents, -9 to the -1/2 power becomes -1/9 to the 1/2 power. Something to note, our exponent is negative. We have a negative in front of the number, but those negatives do not cancel out because one of them is an exponent and the other symbolizes the additive inverse of the number. So we have -1/9 to the 1/2, which is -1 over the square root of 9, but the square root of 9 is 3. So this gives us a final answer of -1/3. Now, as our final example, let's suppose that we are asked to simplify and write our answer in exponential form without negative exponents. 56x to the 4/5 power divided by 4x to the 1/3 power, all raised to the 3rd power. We begin by simplifying the numbers and then using the dividing like basis property. 56 divided by 4 gives us 14. The dividing like basis property tells us to subtract the exponents, so we have x to the 4/5 minus 1/3. All of this is still raised to the 3rd power. 4/5 minus 1/3 gives us x to the 7/15 power. Again, all of this is still raised to the 3rd power. Using the product to a power formula, we distribute the exponent to both terms, so we have 14 to the 3rd power times x to the 7/15 raised to the 3rd power. Finally, using the power to a power formula, we multiply exponents. The 3 cancels with the 3 and the 15 to give us x to the 7/5 power. 14 to the 3rd power then gives us 2,744 for a final answer of 2,744 x to the 7/5 power.